Hello everyone, in this video we're going to be solving what looks like a Nonic equation. Yes, Nonic. Nonic means it's ninth degree. When you raise a third power to the third power, that's going to become ninth power. So let's go ahead and expand this and see what that looks like. We're going to have this 2 plus 3 times. Now if you cube that, I'll usually cube a plus b like this. A cubed plus b cubed and then plus 3ab, that's going to be 18 x to the third multiplied by a plus b. All right, and of course the whole thing must be multiplied by 3. Let's go ahead and expand it. So inside the parentheses we're gonna get something like 24 and then plus 81 x to the ninth power. These two will be multiplied to produce 36x cubed, and times 3, that's going to be 108 x to the third power. And then finally, this multiplied by 18x cubed is going to produce 54x to the ninth, another ninth power. And then we're going to have, basically that is going to be multiplied by 3 again, right? And that should give us 162x to the ninth power. So basically, we are trying to cube this expression. This is a cubed plus b cubed plus 3ab times a plus b. Actually, that's not ninth power. That's going to be the sixth power. Okay. Because 3 plus 3 is 6. So if you arrange these terms a little bit, you're going to get this one first, 81x to the ninth, and then plus 162x to the sixth power. And then 108 x to the third. You're going to subtract x and finally finish with plus 26 equals 0. Like I said earlier, this is a Nonic equation and it cannot be solved because there's no Nonic formula. There's no octic formula, there's no heptic, septic, whatever. There's not even a quintic formula. It stops at quartics. So you can solve the quadratic, the cubic, the quartic with using a formula. I don't think you want to use a formula for the quartic though, because the formula is quite long and pretty complicated. So for Nonics, we can only guess and check. We can do the what is called the rational root theorem. So we can try to look at divisors of this number divided by the divisors of this number, all the possibilities, all the candidates, and then test it out. As you can see, this is going to be super duper painful, right? Obviously, that's going to take a long time. So our thinking should be there must be something special about this equation that allows us to solve it without getting into any of this trouble. So let's take a look at it from another perspective. And let's rewrite the equation. X equals 2 plus 3 times 2 plus 3x cubed to the third power. So something interesting happening with this equation. We have inside the parentheses 2 plus 3 times x cubed. And if you look at the whole thing, I mean this whole thing, then you probably notice a similar structure like 2 plus 3 times something cubed. Make sense? Okay, if that doesn't make sense, let's go ahead and use substitution to make it more clear. Ready? Okay. So we're going to call this expression inside the parentheses. Let's go back and erase all these things and kind of start over. So we're going to go ahead and call this y. Okay. So 2 plus 3x cubed is equal to y. And then by naming that y, we actually get a different equation. The original problem becomes x equals 2 plus 3y cubed. Right? Okay. So, what does that mean? Well, the equations are related. First of all, we had a single equation. We named this thing y, and now we should be getting something like a system, right? Let's go ahead and write the y on the left-hand side. Rewrite this equation. And now take a good look at this system. What do you see? Hopefully you see what I see. Some type of symmetry, right? X is written in terms of y, and y is written in terms of x. the same way. That's what I meant by the structure 2 plus 3 times something cubed. You see what I'm talking about? Okay, great. So now let's go ahead and put this into good use. So since I have the same type of structure, so there's some sort of symmetry, let's go ahead and subtract these equations. So one way to approach it is by subtracting these expressions. So you can look at x minus y. Another approach would be isolate the 2 from both of these equations and then set the 2's equal to each other. No matter how you want to do it, let's go ahead and do the second way. So the first one gives us 2 equals x minus 3y cubed, and second one gives us 2 equals y minus 3x cubed. Since they're both equal to 2, they're equal. So if two things are equal to the same thing, then they are equal. So these two things are equal. So that means y minus 3x cubed equals x minus 3y cubed. And we're going to find out in a little bit what this means. To get a better idea, let's put everything on the same side. Y minus 3x cubed minus x plus 3y cubed is equal to 0. Awesome. So what can you do with something like this? Factoring, right? Let's go ahead and factor by grouping. These two will go well together because they're to the first power, and these two go well together because they're both cubed. So it's going to look like this, y minus x, and obviously I do want to write the y cubed first, following the same pattern, and then the sum is equal to 0. Awesome. Here's what we're going to do now. We're going to make two groups. This is our first group, and this is our second group, and we're going to factor by grouping. So y minus x doesn't really have anything. You can basically take 1 out. So write this as 1 times y minus x. But this one is 3 times y cubed minus x cubed, which is difference of 2 cubes. So I can do the following. Factor difference of 2 cubes. The formula is, this is kind of like a formula. Y squared plus yx plus x squared. X squared, yx and xy by the same thing are the same thing, by the way. And this is equal to 0. Now notice that y minus x is a common factor. That's what I mean by factor by grouping. And then we get 1 plus 3 times y squared plus yx plus x squared. And the whole thing is equal to 0. Great. From here, we get something super duper nice. And that is the first factor being equal to 0. Y minus x equals 0 implies y equals x. And that's nice because if you look at the original problem, x equals, and I kind of need to go back, I guess, not the original one, but the one that I got for my system. So x equals 2 plus 3y cubed. X equals 2 plus 3y cubed. And now y is equal to x, so I can replace y with x. X equals 2 plus 3x cubed. And let's put everything on the same side. 3x cubed minus x plus 2 is equal to 0. Great. So what do you see here? I checked the sum of the coefficients. It's not 0. But when I check the odds, it's equal to evens. Look at this. The sum of these two coefficients equals this one, which means x equals -1 is a solution. I can go ahead and factor this and find the other solutions if there's any. So let's write it as 3x cubed plus 3x squared minus 3x squared plus 3x. Actually, that's supposed to be a minus 3x, not plus. Minus 3x, but I do need a plus. To make it -x, I do need plus 2x and then plus 2. That'll do the job. Now I'm going to factor by grouping again. 3x squared times x plus 1 minus 3x times x plus 1 plus 2 times x plus 1 equals 0. We already knew x plus 1 is a factor and x equals -1 is a solution. But the other factor is going to give us another 2 solutions, which is by the quadratic formula. So x equals -1 is already obtained. And the other solutions come from x equals -b plus minus the square root of b squared, which is 9, minus 4 times 3 times 2. And obviously, they're not going to be real solutions. But if you look at this, this is going to be 24. 9 minus 24 is -15. So the solutions are going to be 3 plus minus the square root of 15i divided by 6. And if you look at the other factor, this is never going to be 0. Why? Because this expression is always positive. You can check it out. Plus 3 times that plus 1 is always going to be positive 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.